last edition, we have discussed the impact of the network decision on the supply chain cost and the framework for the facility design network decision for a supply chain. In this edition, we will discuss the analytical methods in evaluating the locations for facility decisions of a supply chain. The analytical methods for evaluating the locations are given below. Decision-making tools can be used to select the best possible location. The most popular and commonly used ones are factor rating method, break-even analysis, center of gravity method, and geographical information system, which is known as GIS. Let us discuss one by one. The factor rating method. In this method, the various location alternatives are evaluated by rating the relevant factors. The steps involved in this method are: Step 1. Determine the list of most relevant factors needed in the location. Step 2. Determine the rating of each factor on a scale of 1 to 5 based on its importance, where 1 being low and 5 being high. Step 3. Rate each location on a scale of 1 to 10 for each factor, where 1 being low and 10 being high. Then step 4. Calculate the rated points for each location by multiplying the factor rating and the location rating, which has been got in step 2 and step 3 respectively. Step 5. Calculate the total score for each location by summing up the scores calculated in the previous step. Step 6. Select the site that has the maximum number of scores, total scores. This is the process involved in identifying the best possible location using the factor rating method. The next method is the break-even analysis. Cost volume profit analysis or break-even analysis helps us to understand the relationship between total cost and total revenue of a particular location. Based on the total cost and total revenue, we can calculate the point from which profits generate for a particular location. When comparing several potential locations, we can calculate the profit of all locations and choose the best location which earns more profit at an earlier stage onward. The following steps are to be followed in using break-even analysis for the location decision. For each location, we have to determine the fixed cost and variable cost per unit. On a graph, we have to plot the total cost for each location against a particular quantity of volume. Then determine the revenue for the capacity plant. The objective is to find out the break-even point of various locations to make the facility planning decision. The total cost curves of all locations will intersect the revenue curve to give the volume of break-even for each location. From this, we have to identify the best possible location for a quantity plant. Let us consider an example. 4 different locations A, B, C and D are considered for the facility location decision. The fixed costs and the variable costs and the revenue per unit are given below. Let us assume that the quantity demanded is 10,000 units. If the price per unit is rupees 70, we can calculate the total revenue for this quantity. Using the quantity, we have to calculate the total cost for each location and the total revenue as given below. Location A, fixed cost is 2,50,000, variable cost per unit is 11, quantity demanded is 10,000, total variable cost is 1,10,000, the total cost is 1,60,000 and the total revenue earned is 7 lakhs. Similarly, for location B, the fixed cost is 1 lakh, variable cost per unit is 30, quantity is 10,000 units, total variable cost is 3 lakhs, the total cost is 4 lakhs and the total revenue remains same as 7 lakhs. Location C, the fixed cost is 1,50,000, variable cost per unit is 20, quantity is 10,000, the total variable cost is 2 lakhs, the total cost is 3,50,000 and the revenue stands at 7 lakhs. Location D, the fixed cost is 2 lakhs, variable cost per unit is 35, the quantity demanded is 10,000, so the total variable cost is 3,50,000 and the total cost is 5,50,000 and the total revenue earned is 7 lakhs. By calculating this, we will be able to determine the break-even point. Using the above data, let us draw the graph. Let us have quantity in x-axis and the cost in y-axis. In x-axis, 1 unit is equivalent to thousands of units. In y-axis, 1 unit is equivalent to thousands of rupees. The graph drawn is given for your kind reference. We can visualize the intersection of the total cost curves with the total revenue curve, which is known as the break-even point, and it is denoted by P1, P2, P3 and P4. P1 is the break-even point for location B, P2 is the break-even point for location C, P3 is the break-even point for location A, and P4 is the break-even point for location D. From this, we can analyze the break-even quantity for various locations, which will help us in making the facility location decision. Using the same method, if we assume that the revenue per unit is the same regardless of the location where the goods are produced, then the total revenues can be eliminated from consideration and the potential locations can be compared on the basis of their total costs. By using break-even analysis, we can find the location that has the lowest total cost for a given volume range. The following steps are to be followed in using break-even analysis for the facility location decisions. For each location, we have to determine its fixed cost and variable cost per unit. On a graph, we have to plot the total costs for each location against a range of annual production volume. The objective is to find out the location which has the lowest total cost for specific volumes of production. To find out this, we use the breakpoints of the total cost curves. The total cost curves of all locations will intersect each other. The intersection of the total cost curves of various locations are known as the breakpoints. From this, we have to identify the lowest cost curve, which is formed by the cost curves of various locations. Now draw a perpendicular line from the breakpoints of each lowest cost curve. This will give us the range of volumes for which various locations will be suitable. Let us consider an example. 4 different locations A, B, C and D are considered for the facility location decision. The fixed costs and the variable costs are given. Let us assume that the quantity demanded is 10,000 units. Using this quantity, we have to calculate the total cost for each location as given below. Location A, the total cost is 3,60,000. Location B, the total cost is 4 lakhs. Location C, the total cost is 3,50,000. Location D, the total cost is 5,50,000 for producing 10,000 units. Using the above data, we draw the graph. The graph drawn is given for your kind reference. We can visualize the intersection of the total cost curves, which is known as the breakpoints and is denoted by P1, P2, P3 and P4. P1 is the intersection of the total cost curve of location A and location D. P2 is the intersection of the total cost curve of location B and location C. P3 is the intersection of the total cost curve of location A and location B. P4 is the intersection of the total cost curve of location A and location C. From this, we can analyze that the lowest total cost curve is formed with the help of the total cost curves of location B from the initial stage of quantity till the breakpoint P2, say 0 to 5000 units. From this breakpoint P2 to P4, the lowest cost curve is formed with the cost curve of location C, say from 5000 units to 11,000 units. And from the breakpoint P4, the lowest cost curve is formed by the cost curve of location A, say 11,000 units to 16,000 units. So this analysis helps us to find which location is suitable for different quantities to be handled or moved across the supply chain as mentioned in the graph. The center of gravity method. The center of gravity method is a mathematical technique which is used to identify the best possible location for facility decisions. It identifies the location which is equidistant from all the members of the supply chain so that the supply chain cost is minimized. Supply chain costs will depend on several factors such as the weight of the product, the quantity to be supplied, the distance to be traveled, and the speed at which it must travel to satisfy the requirement of the customer. This method assumes that there is a linear relationship between the distribution cost and the distance and quantity shipped. This method makes use of a map with the coordinate systems to identify the coordinates of a central location relative to all other locations which will be cost effective. The geographical information system. The geographical information system is an important tool which is used to analyze the location decision for manufacturing or service industries. It is a computerized system which can store, relate, and display the data collected from a particular geographical location. Geographical information system maintains the databases of geographical information of all places in the global environment, which helps to analyze the various factors of locating a facility decision and suggest the best possible location. Retailers use this geographical information system to identify the best possible location to serve the customers. In this edition, we have discussed the different analytical methods available in evaluating the location decision for deciding the facility decision of a supply chain.